Today we're going to talk about acceleration. Here's your equation, v2 minus v1 over t, and we'll explain what that means here in just a few minutes. Velocity 2 minus velocity 1 divided by time, which means the final velocity minus the initial velocity divided by time. So you take your starting velocity and subtract it from your final velocity and divide it by time. That's where it gets a little tricky for some people because the numbers don't quite look right. They don't look nice mathematically. So when you're doing that, you take your final velocity and subtract your initial velocity and divide it by time. Sometimes you'll have negatives if something is slowing down instead of speeding up. So here's one question we're going to do together. A car uniformly accelerates from 18.5 meters per second to 46.1 meters per second in 2.47 seconds. Can the acceleration of the car be determined? And it can. So you're going to use your equation here, just like we talked about, your final velocity and subtract the initial velocity divided by time. And here's what we would do when we substitute it. Now if you look up here where it says from 18.5, so that's going to be your starting velocity, so that's going to be v1 divided by 46.1 meters per second in 2.47 seconds. So you're going to subtract 46.1 minus 18.5 divided by 2.47, and that gives you 11.17 meters per second or meters per second squared. Whichever way you want to indicate that is fine. Here's another one. Bike accelerates uniformly from a rest to a speed of 7.1 meters per second in a time of 35.4 seconds. Determine the acceleration of the bike. So we don't know the initial speed, except it says here from rest. So initial speed from rest would be 0. So if we go from rest to 7.1 and we set it up with our equation, here's what that's going to look like. It'll be 7.1 minus 0 because we finished at 7.1 meters per second, divided by 35.4 seconds, and you get 0.2 meters per second or meters per second squared. A car traveling at 22.4 meters per second skids to a stop in 2.55 seconds. Determine the acceleration. So this one goes the other way. It's going 22.4 and skids to a stop, and a stop would be 0 meters per second. So if you use your equation, you would have 0 minus 22.4 because 0 is your final speed because it skidded to a stop, and subtract the initial speed. Divide it by the time, and you get negative 8.78 meters per second or meters per second squared. So whenever you see something that is negative or something that is slowing down, you're going to know that your number is negative. It has to be. Here's another example. A roller coaster car rapidly picks up speed as it rolls down a slope. As it starts down the slope, its speed is 4 meters per second, but 3 seconds later, at the bottom of the slope, its speed is 22 meters per second squared. Sorry, meters per second. What's the average acceleration? So you would use your equation for acceleration. 22 minus 4, because 22 is what your final speed was, what it ended up as. And then you subtract the initial speed of 4 meters per second divided by 3 seconds, gives you 6 meters per second squared. A cyclist accelerates from 0 to 8 meters per second in 3 seconds. What's his acceleration? Is it higher than a car's acceleration that goes from 0 to 30 in 8 seconds? So you're going to do two different problems here. The first one, 8 minus 0 divided by 3 is 2.67 meters per second squared. And then you have 30 minus 0 divided by 8, which is 3.75 meters per second squared. So the acceleration of the car would be greater, just as you thought it would. A lizard accelerates from 2 meters per second to 10 meters per second in 4 seconds. What's the lizard's average acceleration? Let me use your equation here. 10 is its final speed. Subtract 2 as the initial speed and divide by 4, which gives you 8 divided by 4, which equals 2 meters per second squared. A runner covers the last stretch of a race in 4 seconds. During that time, he speeds up from 5 to 9 meters per second. What's the runner's acceleration? So again, we'll start with the equation. Substitute 9 minus 5 divided by 4, which equals 1 meter per second squared. Traveling in a car that's moving at a velocity of 20 meters per second, suddenly a car 10 meters in front of you slams on its brakes. At that moment, you also slam on your brakes and slow down to 5 meters per second. Calculate the acceleration if it took 2 seconds to slow down your car. So there's a number in here that you don't need, and that's the 10 meters in front of you. If you were going to figure out if you would hit the car in front of you or not, that would be helpful, but we're not doing that right now. So you're going to use your equation. 5 minus 20, since you're slowing down, you should know you should have a negative number. And then negative 15 divided by 2 is negative 7.5 meters per second squared.